Assalamualaikum warahmatullahi wabarakatuh and hello. My name is Feraaz Ahmad bin Israr Ahmad. My matrix number is 139236. My group will be presenting about radiography testing. So I will be discussing about what is radiography testing. So first of all, let me give a little bit of history about radiography testing. For the history of radiography testing, the first two people that discovered radiography testing are Wilhelm Conrad Röntgen in 1895 and the second one is Marie Curie in 1898. W. C. Röntgen used radiography testing in medical radiography. So, radiography testing. Radiography testing is a non-destructive testing method which uses either X-ray or gamma ray to examine the internal structure of manufactured components to identify the defects. Although this is a slow and expensive method, this is a suitable way to test welded joints that can be accessed from both sides, and it is a dependable way to detect porosity, inclusions, cracks, and voids in weld interiors, and it uses X-ray or gamma ray. Okay, there are two types of radiography testing. The first one will be conventional radiography and the second one is digital radiography. Conventional radiography. Conventional radiography uses a sensitive film which reacts to the emitted radiation to capture an image that is being tested. But digital radiography, it doesn't require a film. It uses a digital detector to display radiographic images that can be interpreted more quickly than conventional method. There are four types of radiography, digital radiography. The first one will be computed radiography. The second one is direct radiography. The third one is real-time radiography, and the fourth one is computed tomography. Okay, now I'll be discussing about the principles of radiography testing. Okay, X-rays and gamma radiation have wavelengths shorter than 100 nanometers. At this short wavelength, energy can penetrate through solid materials. The shorter the wavelength, the greater the penetration will be. Just like visible light, X-rays and gamma radiation also have a photochemical effect on silver halide and can therefore produce an image on film. So by passing penetration radiation through an object uh, and recording the imaging radiation on a film, a two-dimensional picture of the difference in thickness and density of the object can be obtained. This will provide us with the flaws in the object, so it can be detected by radiography testing.
Assalamualaikum and a very good evening. My name is Taufiq by Rahim. I'm from Group 7. So I'm in charge of explaining mechanism of industrial radiography. So the first one is about industrial radiography. Radiography is useful because does not damage or change the item being tested. So it can be used when it is difficult or not practical to access the material being inspected. So for the example of radiography process, some of it are medical X-ray used to find cracked bones. Industrial radiography use X-ray or gamma ray to take picture product because they can show problems that are not visible by the naked eyes. The last one is industrial radiography, which is used to test gas, oil pipelines, metal welding, and vehicles. The next one is equipment required for the radiography. So there are many different tools used. So for the common tool that are used, there are three, which is X-ray and gamma ray source, recording medium, and processing equipment. For the X-ray and gamma ray source, X-ray generator or gamma ray source via radioactive material, a source which is most necessary aspect of industrial radiography. With smaller part components, so depending on the product requirement, industrial radiography of X-ray testing approach can be utilized. If the part is large and it requires high amount of radiation exposure in order to penetrate the material, gamma ray source will be more suitable. So for the smaller part component, ranging from plastic to metal, the X-ray will be better. So for recording medium, there are two they are be used nowadays, which is computed tomography and digital radiography. So for the digital radiography, the one that we usually use is the radiography camera, which we explain later. Then the last one is processing equipment. It is used to develop, restructure, and analyzing the resulting image. So the difference of X-ray and gamma ray industrial radiography devices is for the radiography, it is powered by electric. So when it is turned off, it can be used. It provides clear pictures, and the devices are large and used for factories. For the gamma radiography, it is different because it does not use the electricity, so it is better. And it, it is it is smaller, which is the small size make them useful for checking inside pipes, ship, and other small spaces. However, it can't be turned off. Actually we have to put a metal plate to avoid the gamma ray to penetrate. So for the next one is a radiography camera. Most industry are moving from films based radiography to digital sensor radiography, which is same way that traditional photography have made this move. Since the amount of radiation emerging from opposite side of the material can be detected and measured, variation this amount or intensity of radiation are used to determine thickness or compositions of materials. So there are two examples, which is torch design and cable design. This is for the torch design. They have two design. The first one, they have hinge. The radioactive source is red. The shading is blue or green, and the gamma ray is yellow. For the second one, is uses wheel. The radioactive source is red, and the gamma ray is yellow. So the others, this is like cable design. The schematic show the internal of the portable or handheld radiography camera, which is used to capture radiography pictures. Such system uses typically iridium-192 as the gamma source. So the image will be projected at the films, or at the left, at the right, at the films. So the source will be put inside the exposure devices. So this is the example of the radiograph, which means after being processed. So a radiography source will detect the void and the darker area. After processing, we produce a black, which is radiograph is a negative. The thinner area will be appear darker. Next is fundamental of X-ray imaging. So this is type of X-ray which the result will be produced at the computer image processing and analysis, and the focal. Yeah, conversely, if a high density inclusion is present within the casting, the level of attenuation will be increased. The imaging devices record the X-ray energy level impinging on the input phase, and from the information, a two-dimensional X-ray image will produce. So from the last one is contrast agent used in radiography. Defects such as delimation and planar cracks are difficult to detect using radiography, which is why penetrant are often used to enhance the contrast in the detections of such defect. So penetrant that are used usually are silver nitrate, zinc iodide, chloroform, and diodometine. The choice of penetrant is determined by the ease of which it can penetrate the crack, and it also which it can be removed. Diiodomethane has an advantage of high opacity, ease of penetration, and ease of removal because it evaporates relatively quickly. However, it can cause skin burns. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq bin Anuar. My biometric ID is 138933. Okay, I want to talk about the application of industrial radiography. So, what are the application of industrial radiography? Okay, there are various application of industrial radiography in industry actually. Each of the uses of this non-destructive method is very crucial in avoiding accident in a bigger scale. The damage in a machine can be detected using the radiography technique. Radiography and X-ray testing is one of the most common non-destructive testing methods within the industrial sector. Okay, from having the ability to inspect, quantify and qualify failures and defects to being able to access internal and external geometry. Industrial radiography has become an indispensable tool for the industry. Application vary depending on the type of material, size of part, and inspection requirements. Although industrial radiography and X-ray inspection are commonly used for testing wires, pipeline, concrete, machine parts, and metal components, solid and flat materials. Inspection of new products and well. Okay, this is the first application of the industrial radiography, which I want to talk about. First is about industrial radiography is used in the inspection of new product and wells to ensure they meet the requirement of the relevant standards of construction. New pipelines, including bends and joints, storage container, and even insulated material are routinely inspected using radiography. Okay, we will inspect new product and wells. So that is the most important parts. And measurement of internal flaws in existing plant, like oil and gas plant. Okay. So another common use for industrial radiography is the detection and measurement of internal flaws in existing plant. The early detection of internal flaws in pipelines and plant in the oil and gas sector, for example, is essential for maintaining production flow and for the prevention of potential disastrous hydrocarbon spill. Okay, so we just have to detect. We don't have to dig the pipe to see it. No, we have to detect it using radiography. That is important. Detection of corrosion under insulation, which is called CUI. Detection of corrosion under insulation (CUI) is another common application for radiography. Operators can pinpoint any defect without the costly and time-consuming process of removing and pressing the insulation. Yeah, this is like the process I talked about. It is time-consuming. Next is used in security. Anti-radiography is also used in security. There are now devices available for inspecting suspicious packages and objects, which eliminates the need for dangerous, intrusive, or manual inspection methods. So we don't have to open the package, we just have to scan it with radiography testing, and then we will know what the object in it. So an important part is security. This is for military. Industrial radiography are widely used in rocket and aviation industry and also in many special military areas. Typical technical objects of non-destructive testing are different kinds of connection of materials, welded and soldered in glue joints, etc., as well as construction elements made from composite materials. Composite materials are often more practical to be used for different military applications. Automotive. The ability of X-ray radiation, which is the radiography, is to penetrate engineering materials permit inspection system to image and measure hidden features. The automotive industry uses this technology as part of a growing need for Six Sigma quality assurance and product traceability to limit liability and improve product quality. So we can detect the hidden features in the images of the radiography.
Assalamualaikum and very good evening. My name is Adzlan Bin Hari. My metric number is 138915. So today I want to talk about safety on industrial radiography. It is important to know the safety and precautions on how to handle the radiation materials. If we take it easy, it can cause a major problem to our health. Firstly, I want to talk about the radiation hazard. The disadvantages of radiography is the health risk associated with the radiations. The amount of risk depends on the amount of radiation dose received, the time over which the dose is received, and the body parts exposed. I will explain it later on the next slides. And next, the active flow all over the world require that individuals working in the field of radiography must receive training on the safe handling and use of radioactive materials and radiation producing devices. Today, it can be said that radiation ranks among the most truly investigated causes of this. The primary risk from the occupational radiation exposure is an increased risk of cancer. Okay, as I said before, the amount of heart risk depends on these several factors. The first one is type of radiation involved. All kind of ionizing radiation can produce heart effect. The main difference is the amount of energy they have. For example, alpha, beta, and gamma. The energy determines how far they can penetrate into tissue and how much energy they are able to transmit directly or indirectly to tissues. Second, size of dose received. The higher the dose of radiation received, the higher the likelihood of heart effects. Third is rate at which the dose is received. Tissue can receive larger dosage over a period of time. If the dosage occurs over a number of days or weeks, the results are often not as serious if a similar dose was received in a matter of minutes. That means the immediate radiation that emits by the source are more dangerous than the radiation that takes days or weeks. Fourth, part of the body exposed. Extremities such as hands or feet are able to receive a greater amount of radiation, but less resulting damage than the blood-forming organs in the upper body. 5. The age of the individuals. As a person ages, cell division slows, and the body is less sensitive to the effect of ionizing radiation. Show the figure of radiation effects to our body. Radiation effects can be divided into three levels, which is tolerable levels, moderate risk, and high risk. The tolerable levels show no symptoms, no detectable increased risk of cancer, while moderate risk, no immediate symptoms, but increased risk of serious illness later in life. And high risk, potentially fatal radiation sickness, much higher risk of cancer later in life. This is very dangerous. Example, if we receive 10,000 millisievert radiations, it can bring fatal within days. Other than that, if our body parts are exposed to radiations, it can bring fatal into eyes, thyroids, lungs, stomach, reproductive organs, skins, and bone marrow. Okay, now radiation safety instructions. All the fatal that caused by the radiations can be prevented if we follow these following instructions. The first one is to understand the symbols. All these three symbols means radiation sources. If you saw the symbol in the building, it means the building are handling radioactive materials. This symbols is used as a warning to protect people from being exposed to radioactivity. Okay, second, understand who takes care of safety. Every institution or factories has their own radiation safety official. Find out who your RSO and always follow their instructions. Okay, third, understand the do's and don'ts. First, never operate the camera by yourself. Do not place the camera where it is likely to get stolen or lost. Do not handle the camera without instruction from certified radiographers. Report to RSO if the camera falls from the height or scaffolding. If the pigtail comes out or falls from the camera, keep safe distance or run away from the pigtails and inform your RSO. This is because the pigtails is where the radioactive assemble. Even when the camera is not operating, the radiation is continuously emit. So it is important to make sure the pigtail is always inside the camera. Fourth, understand safety principle to control radiation exposure. The three basic controlling exposure is limiting the time, increasing the distance, and using shielding. Okay, time. The radiation dose is directly proportional to the time spent in radiation. Therefore, a person should not stay near a source of radiation any longer than necessary. If you minimize the time, and you will minimize the dose. The dose can be simply calculated as dose equal to dose rate times time. Distance. Increasing distance from the source of radiation will reduce the amount of radiation received. As far as you from the source, then the radiation is less intense. Use forceps, tongs, and tails to increase your distance from the source. Shielding. The third way to reduce exposure to radiation is to place something between the radiographer and the source of radiation. In general, the more dense the material, the more shielding it will provide. Lead and concrete are the most commonly used radiation shielding materials primarily because they are easy to work and are readily available materials. So here I attach the figure on how to controlling exposure to harmful radiations. And for time, the less time and then less radiation received, and distance we keep as far as possible, then less radiation received. And for shieldings, the more dense the shield, then the more shield it will provide. Here also I attach a link of video on how to controlling the exposure radiations. Also, I attach a figure show the penetrability of radiation sources for alpha, beta, and gamma. Gamma have the higher energy because it can penetrate paper, plexiglass, but it cannot penetrate lead. About the basic laboratory rules. First, smoking, eating, and drinking are not permitted in the radionuclide laboratories. If our food and drinks are exposed to radiation, it can bring fatals to our body. Second, food and food containers are not permitted in the laboratories. Third, radionuclide works area should be clearly designated and should be isolated from the rest of the laboratory. Fourth, PPE should be worn. And five, dosimeter also should be used when working with large quantity of radioactive. And lastly, all contaminated waste shall be tagged and placed in specifically designated for radioactive waste. Later, I will explain on how to dispose the radioactive waste. Okay, this slide show the personal protective equipment and dosimeter. Personal protective equipment or PPE such as coat, gloves, disposal shoes cover, and goggles. While dosimeter has two types, which is DRD and TLD. The function of dosimeter is to measure the radioactive radiation. Okay, now I will explain about on how to dispose radioactive waste. First, label must provide sufficient information on the container to minimize exposure and to make sure all proper precautions have been taken, such as type of radionuclides, estimated activity, and date. Second, keep container closed and secure. And third, keep a tag on container at all times. This is example on how to labels and tag a container. So here are a few questions and answer regarding the industrial radiography. Question 1 is, does dosimeter or DRV protect me from radiations? The answer is no, the DRV does not protect you from radiations. It only measures the radiation dose you might have received. Question 2, does radiation will cause cancer? The answer is, when we talk to cancer with respect to radiation, we talk only the risks involved. The risk of cancer on exposure to radiations within limits is very small and not distinguishable among other possible causes of cancer. Question 3. Now that I know about the equipment, can I operate it? The answer is no. You cannot operate. The camera should be operated only by certified radiographer. Question 4. Is the X-ray in X-ray clinic and from radiography camera is same? The answer is no. The X-ray strength in the clinic are much lower than the X-ray radiography camera in industry. The X-ray in industry can cause severe even with seconds of exposures in case of accidental situation. So that's all from me. Thank you.